Hello, everyone. Um, my name is John Wallace. I am the head of sales and business development of Inverbis. And today we have this webinar to show you a few things about how our joint solution with Time Extender can help you break down your data silos and take advantage of the power of process mining at the same time. I'm going to be sharing this webinar with Frank Wagner from Time Extender, so he'll jump in when the time comes. But for now, I'm going to start by giving you a sort of short overview of what we're going to see, what the process mining is, what the challenges are, and how we can use Time Extender to overcome these challenges. So I'll switch to the slides. I have a very brief presentation, and then we'll do a live demo so you can see how this all works in practice. Okay, so without further ado, let's start. First thing is, what is process mining really? Well, process mining is a discipline within analytics that actually extracts the digital footprint of a process from corporate systems, so that we can actually see, discover, and analyze the execution in real life. So many times we have these processes that have been designed that are maybe sitting there in a process manual or an ISO 21000, audit manual or whatever, but we don't really understand if they're being executed in the way they were designed. So what we do with process mining is we go into either the logs or the transactional systems. We extract the information of how this process is actually being executed, and we can then show it so that it can be analyzed and it can be improved. So what are the uses of this? Well, first, you can visualize and see how your process is really being executed. As I said before, generally, it's not being executed in the way that you designed it or that you expect it to be working. The process mining tools also provide the data to explore this behavior, to explore the different paths, the different ways the process is being executed, either individually or in an aggregated manner. You can also drill down and filter specific behaviors so that you can get insights into why things are being executed the way they're executed. You can also compare these executions and benchmark between departments, between regions, between sites, between teams, etc., etc. And you can then define and track process KPIs and monitor them in real time if you need to, so that you can complement, let's say, your traditional dashboards where you have your regular KPIs. You can complement them with a process view of where the process is breaking down, etc., etc. And finally, you can provide insights into the future behavior of these executions. What's going to happen? You can predict on how these executions are going to impact your business, how they're going to be executed, what the times are, etc., etc. What are the typical use cases of process mining? Well, the first one is obvious. It's a process improvement to identify waste, repetitions, reduce bottlenecks, etc., etc. You can also use it to identify automation opportunities. So you can understand your process and see which are not only the points where you can automate, but even the different variants that you can automate. You can find that automating a process is not as straightforward as it seems, because it doesn't always follow the same path. So you can even select, what the paths are that can have the most value in automation. You can evaluate compliance against, your designed or your expected process in situations where, for regulatory purposes, for example, you need to follow strictly a series of steps. With this, you can actually evaluate if you're doing that or not, and how much you're deviating from that. You can predict behaviors and simulate outcomes, as I said earlier. And you can enhance your monitoring capabilities with process KPIs, and you can do this in real time. So as I said before, a different perspective from your traditional KPIs. And finally, there's another category of use cases where you can use it to support large IT systems migration. So you have a system like an ERP, which is process-based, and you have a lot of processes in the original system. You might want to look at them before you migrate everything to the new system to understand if they're being followed, if they're being used, if you can optimize something before migrating, etc., etc. How does this actually work? Well, the process mining tools extract the data, as I said, from the logs or from some transactional systems, and basically what you need to be able to mine a process is a series of fields. The first one is a trace ID that we call, which is a unique identifier. That is the one that's going to link different activities together to form the process. So if you're tracking, for example, an ordering process, this identifier might be the order number, and this links the activities together to form the execution of the process. You need those activities or the events that are actually happening, and you also need a timestamp. You can have one timestamp or two, and depending on if you have one or two, you can measure, times between activities or activity times and times between activities, both things. And then you have a series of attributes, and these are important because these are the ones that are going to help you really gain insights on why the execution of your process is going the way that you're seeing it. So you have things like who is executing the process, what resources are being used, what type of process it is, what type of order, et cetera, anything that can have an impact on the process is useful to have here so that you can then derive insights from it. Now, as with everything in data, it's not as simple as it looks. I mean, you have to extract all this data, and although the basic underlying model of process mining is quite simple, populating it is not that simple, and especially when a process crosses several systems. So if you have a process that is contained within one system, within your ERP, then it becomes simpler because generally you know where the data is and it's all in one single system, and you can extract it and process it and load it into your process mining tool. But when you have a process that crosses several systems, it starts to become a little bit harder. So you might have an ordering process that starts in your CRM where the order is created. Then you have the production being managed by a manufacturing execution system where the product is produced. Then you might have that it goes into a logistics system where warehousing and shipping are managed, and finally ends up in an ERP system where the invoicing, for example, is done. So in this case, you would have to deal with 4 different systems, with 4 different data models, with different information is in different places, and maybe you need to do some transformations to build a coherent view of the process across all these systems, right? And this is the challenge, and here is where Time Extender can be a key tool in order to greatly simplify the process. And here I'm going to hand it over to Frank Wagner from Time Extender, who's going to tell you a little bit more about this.
Thank you. Thanks, John. So the exact challenge that John just mentioned is what we are dedicating our time to since more than 16 years. Time Extender started out as a data consultancy, but then we noticed even with all the consultants in the world, we will not be able to help everybody, and that is why we focus today on providing a solution, basically a software product that helps customers all around the world solving exactly those data challenges, right? Getting the data out of distributed systems, which are more and more diverse and complex, and bundling them together. That being said, as I said, we have a track record of 16 years in the business, in the market. So we are not a new player. We are not a beta software. This is an established solution that really works, and we have a track record of 3,500 customers around the world, distributed through our network of trusted partners. Inverbis is one of our very trusted partners in this space. And as you can imagine, and as you all probably know, that these data challenges are not specific to any one industry, and that is why you can see, for example, on the 4 case studies that I have highlighted here, these things go across all the industries, across all, all companies have the same challenges with that regard. So John, can you just skip one forward? Perfect. And why is it so difficult? I think we already have seen like 4 or 5 systems that we maybe touch on. And in a traditional approach, if you want to consolidate this data from these various systems on the left side, it can be relational data sources. It also is flat files. Typically nowadays, it's even more complicated with distributed systems in the cloud. And in order to get it out to the consumers of the data, be it a reporting front end like Power BI, Tableau, or Click, or be it a process mining solution to give you further insight, whichever use case you have for your data, in order to get it from the source to the consumer, you typically build out these kind of what I call the spaghetti pipeline monster, right? So it's a very complicated and laborious process involving a lot of technologies and also requiring a lot of skills and expensive data engineers, which are more and more rare today. And that is why it's so complicated, and that is also why we see companies and customers typically don't leverage all the value they have in their data. Can you go to the next one, please? So our approach is that this needs to be simplified by a lot, because everybody should be able to leverage their data to get the insights they need in a reporting front end, in a process mining solution, to get the insights that you really need, because the data is yours and you should get all the value from it. So Time Extender will give you one unified interface to connect to more than 250 data sources, ingest the data, so decouple it from the data source, prepare it, relate it to one another, apply data quality rules, clean it, apply transformations, add additional attributes to it. So all the things that you need to enrich the data so that you can, in the end, in the process mining process, get the most value and the most insights from it. And this is what it will look like in combination between Time Extender and Inverbis. So we can take the log files, as John mentioned, but we can also connect to structured sources and to business applications, to all the various data sources you have, connect them with Time Extender using what we call the ODX, the Operational Data Exchange. So get the data out of the sources, land it into your data environment. In the MDW, the Modern Data Warehouse, the second stage of Time Extender, we can bring the data together, relate it to one another, apply data quality, add transformations, make it clean, make it behave, so to speak, and then serve the data out in a semantic model to reporting front ends and to process mining with Inverbis, where we can get all the insights from, but also where we can get additional insights, which then feed back again to your data estate, and you can also make them visible and persistent for your business users. So this really gives you the end-to-end process we are looking for.
Okay, thank you very much, Frank. This was an overview of how we use both solutions together, and we have a connector that integrates both solutions so that you can work with, and we'll show you in a minute, so you can work with Time Extender, and then the data can be automatically imported into Inverbis for use for process mining. So what we're going to do now is we're going to dive into a live demo where we're going to show you this process, show you how it works in practice, and we're going to see some insights that you might have from a process like this, and what the dashboards might look like. So what we've done with this is we selected, an example of a use case where we would have 2 source systems. So this case would be a telco, and this telco has its incident management process, divided into these 2 systems. Generally, they have many more than this, but let's simplify the case. So The CRM is where the incidents from the clients are created by the call center, and if it can be resolved there, fine. But if they need to send a technician, if there needs to be a field service intervention, then and that's managed by a different system, which is the field service management system, where these field service calls and the technicians and the process of solving problems at the customer's premises is managed, right? So we've got two source systems, and there we have to unify this to get a unified view of the end-to-end process from when the customer calls to when the incident is resolved, if it's resolved in their premises. So what we're going to show basically is how to use time extender to access these two different sources, how to transform the data and compose the end-to-end execution of that process, how this is loaded into Invervis, and then we will see a few insights of what we can get from this data once it's in the process mining platform, and how we can see this in some dashboarding capabilities. So without further discussion, let's dive straight into the case demo.
All right, let's do this, John. So the first step, as we discussed, is the first thing I need to do is I need to connect to the data and need to get the data out, right? So this is the first crucial part, of course, in order to be able to consolidate everything and relate it together. So the way we do it is in the time extender portal, I can have all of these connectivity options with more than 250 different data sources. I have configured just a couple of them to give you an overview of what's possible, but again, of course, there's a lot more things possible. So you can see a whole list of data connectivity options here that are just examples of what you can do. So for example, of course, we can do SQL data sources. We can do REST APIs. We can do CRM systems, in this case, for example, Dynamics. You can feed in Excel files for additional master data to enrich your attributes. Of course, you can have CSV files, Postgres, databases, ITSM software like Jira or other ticketing systems. You can, of course, have Oracle databases, SAP, if that's what you're using. Old but gold SharePoint lists, of course, ServiceNow ticketing systems, XML files, all the data sources that you have, there's a whole list of connectivity options that you can really use. So the things that are configured here are basically connection strings, to information to where to get the data from, how to authenticate, and how to log in and connect to that data. Once I have done that, we can jump over to Time Extender, which is the modeling client in this case. So how do we really get the data out? And here is where we model the process, basically. And it looks very similar to the schematic drawing that I've shown you before. You have over here what we call the ODX, which is where you connect to the data sources. We have the data warehouse in the middle where we make it behave. And then we have, in this case here, the executions, which is where we push it out to Invervis, to the process mining platform. So the first step is to add a new data source. And you can see, for example, we have the field service management data source already in here, and it's already part of our data warehouse. So now is the question, we need the CRM data also in there because the process is scattered. So some steps are recorded in the CRM system and other steps are mentioned in the field service management system. So to add a new data source, we do the whole process end to end. I just go in here and add here my CRM system. Then I can choose from the connection strings that we have configured in the portal. So in this case, you can see it's just 3 of them connected here, but we have seen all the connectivity options that we have. I will just choose this one. Now I'm already connected live to my data source, and it can be any data source of the ones that you have seen on the portal. You're already now live connected. And you can already get a preview of the tables of the data that's in there. So this is really a live connection to the database. We will add this data to our extraction process. I will give it a transfer task to really move the data out. And this is also what you would then later on schedule, let's say during the night or once an hour, every 5 minutes, you know, how close to real time you want to be. You can go down to the minute level basically here. So now the data is transferred. I have already connected and extracted it to my database. And now let's have a look. How can we really consolidate this in our data warehouse? So in the data warehouse, we already have this table here, field service events, and you can see the fields that John also mentioned before. So you have a trace ID, basically relating different events together. The activity gives us an information about which step we are talking about. Then we have 2 timestamps here, start and end. And we also have a classification about what has been done in this particular case in this ticket, the actuation result. We also have a classifier about where has it happened, etc., etc. So different informations. We also add some fields here for the housekeeping in the warehouse. That is something that Time Extender gives you out of the box. So how do we add the new data source to this? So here under mappings, you can see this is being fed from the field service data source. And now we have added a new data source that is called myCRM. We can just search it. And now all I need to do is basically just drag it across to consolidate the 2 data sources. I get different options how I can consolidate the 2 together. In this case, I will go with Smart Synchronize. And now you can see the table has received a second mapping, the field service events, and now we also have the CRM events here. You can also see that the table is now what we call uneven, because the table itself has 2 mappings, but certain fields could not be matched automatically, right? And this is where this gives you a lot of automation, but also the flexibility to make changes where it's necessary in a manual way. So let's say I need to adjust the mapping for the start, the end, and the center here, the call center that has not been matched automatically. So I just select the new data source, and I can see under data movement all the columns that it has. I can see in bold the ones that have already been mapped, and I can see others have not been mapped. So apparently the new data source has a different naming for certain columns, but others are just the same. So begin is probably the start timestamp, and stop is probably the end timestamp. And then the call center is the center, right? And now the mapping is even, so all columns have the same amount of mappings. And now the message also goes away because now the table is even. So that is great. Now let's add another step to this because I want some additional classification. We have the actuation result, but let's say there is 400 different actions that could have been taken. Now I want to classify them into just a couple of categories to get a better overview in the process mining, because otherwise if I want to classify across 400 types of actions, that's a bit overwhelming. So for that, I have a lookup table already here prepared. It is empty so far. So let's maybe load some values in here to have a lookup and to really enrich the events data. I go to custom data. In this case, I can load it, from a SharePoint list. In this case, I choose to import it ad hoc from an Excel file. Import the data, open my Excel file. It has 2 columns, the action type and the actuation result, right? So we just load those 2, and the actuation result is what we have already in our field service events, and the action type is what we want to classify it into as a broader category. So that is good. Now we have the data in the table here. Now how do we relate it together? So I have an actuation result here, and I also have the actuation result up here in the field service events. So all I need to do to relate them together, I just drag and drop it across, create a relationship. Time Extender will build all of this out on a metadata level. And that is super important for you because that means it is repeatable. So all the blueprint that I built now, I can repeat over and over again. I can execute it every night, every hour, every 5 minutes, and I will always have up-to-date data following the same preparation steps. And now let's also take the action type, so the broader category name, and what we call denormalize into this field service events table to really add this lookup and add the category to the actual table here. So now you can see the two tables are marked in red. A couple of things have happened here in Time Extender, but now it's maybe time to process, deploy, and execute. So now we will really make this part of the database and also populate it with real-time data. I will add a version comment because all of this is, of course, version controlled, and you can always go back to a previous version. And now this is being processed. Time Extender will take care of all the execution for you, and it will do all the orchestration, so all the things happen in the right order, but always in the shortest amount of time possible. And now we can already have a look at our new field service event table. And if we scroll a bit to the right, we can see the action type here, which is the category that we've just added. We can also take it one step further and let's say do an aggregate table already in here, which is nice for analytics, maybe add it to a Power BI dashboard later. And say we want to do an activity summary, and I want to group it by the trace ID. That makes it a bit wider. And then we do in here a count and a distinct count. And this will be the activity count, and this will be the process count. And I'm just giving you some examples now, how you want to enrich your data and how many transformations you want to do. It's really up to you. This gives you all the flexibility that you need to build this out. And in this case, we can now do a preview, and it will tell us how many steps are in each of the processes and so on. So these are just some of the things you can do in Time Extender. There's a whole lot of more possibilities and features and transformations available in here. But of course, today we want to use this to push the data out from here and upload it to Inverbis. This, of course, can also be scheduled, but I will just execute it now ad hoc and press the execution button here on this custom action that we have. This will push it out now to the Inverbis process mining platform. And John will tell us a bit how that works.
Okay, thanks, Frank. So as you can see, it's now being pushed into the Inverbis platform. It's this telcox file here that you can see is processing, and what we're doing here is we're gathering all that information that it would have taken a lot of time and effort to actually map, extract, transform, and then load this data into the Inverbis platform. But as you have seen with Frank, using Time Extender, both the access to the systems and the mapping of the different fields and the transformation that we would need to do. In this case, it was very simple, but we need to do some more complicated transformations. Can all be very simplified very much and then operationalized using the Time Extender platform. And therefore, we can break these silos from the CRM system and the field management system, field service management system, to create a single trace of a single process. So now I'm going to go into the file that was pushed over by Time Extender here, right? And as you can see, it has now been populated with information. We have brought in 5,540 cases, which with 18 variants, that is 18 different paths that the process has taken. If we look here at the trace viewer, we will see the data model that Frank was preparing within time extender. So we have our trace IDs, we have our activities, our timestamps, and then we have a series of attributes here. The action type attribute, which was the one that was created ad hoc within time extender, is here. We have the result of the field service call here. We have the result of the call center call here. We have the type of incident that is related to the incident that we're processing. We have the center, etc., etc. So we've got all the data now in Imbervis, and I'm going to show you very briefly some of the things that we can do with it. Of course, it's going to be a very brief overview, but starting with what we see here, what we're seeing here is the most executed path or the most executed version of the process. So this has been executed almost 2,000 times, as you can see here. And this seems to be the, let's say, standard or a happy path of the process when it's solved by the call center. So a new incident is created, it's assigned to a call center group, they work on it, they solve it, and then they close the incident, and that's it. So that's the most execution version. But as you can see, there are 18 of these. So if we click on variant browser, we have the most executed one, but then we can go to the second one. And here you can see the execution is different. This looks to be the standard process for when a field service call has to be made. So here you have the new incident is created and it's assigned to a call center group. Then they work on it. They can't solve it online, so they open a work order for the field service team. Then they schedule a visit. They confirm this visit. They visit the client's premises. They execute the work order. They close it, and the incident is closed. So this is, let's call it the standard or the happy path for when field service is involved. Now we can look at it not only in terms of times it's been executed, 1,500, but the durations, right? So if we go into here, we can see the durations of the different steps, and since we have two timestamps of the transitions between steps, and here you start to see interesting things. For example, when you have to derive the incident to field service, call center only spends 3 minutes in it, right? If we go back to our call center standard process, you can see that when they solve it online, when they solve it at the call center, they spend on average 5 minutes, right? Now, this tells me that maybe one of two things are happening, or they have a very good analysis process where it takes them very, very little time to identify that the problem should be derived to field service because it cannot be fixed online, or they're just pushing quite a few things out to field service without really dedicating enough time to the analysis, right? We can dive deeper into this through a filtering application. And what we need to do first is we need to add a filter. We have filters for all the attributes here. We need to add a filter here to filter out the things that are resolved in the call center. So if the call result is report open, right? This is when a work order has been opened, right? If we filter this, right, you see we've got 3,480 cases right now. We filtered out all the ones that were resolved by the call center. So now we have only the ones that are actually sent to the field service to be resolved. And then we can add another filter in which we can check for what the result of the work of the field service team was, right? So if we go here for actuation result, and we put in here no fault, this is what the field service team reports when they go over and either it wasn't a problem or there was something that a slight configuration or something that really could have been done probably online and really didn't need for them to go. And what we find here is interesting. The number of cases where the field service team reports that there's no fault is 1,161. So massive number of cases. And more interesting, in most of these, so 795 of these cases, actually the call center took even less time to open the work order. So we have even 2 minutes. So this sort of reinforces the theory that maybe the call center in many situations are just pushing over these incidents to field service that then go over there and find that there is nothing really field servicey, let's say, to do in the client's premise, and that could be solved in another way. So we're getting some insights here, right? Now, if we go back to our variant browser, obviously we have, quite a few variants here. For example, if we go to the third variant, we start seeing a loop here. So it's in progress. The call center is trying to solve it. They declare it as solved, but some time later, and actually if we click on duration, we see that it's 6 hours later on average, the client calls back and it has to be reopened and then finally passed over to field service and a work order is open, right? So we have a loop here in the process, which obviously is hindering our meeting the SLAs for this process. Actually, we have a dedicated tab for this, which is our loop inspector. So this automatically detects all the loops in the process. So here we have the one I just spoke about, reopening the issue. But we have another 2 loops. So if I click on this one, I have another loop, and this one seems to be they open the work order, they schedule it, they confirm it, they go to do the work, but for some reason they couldn't finish it or they couldn't actually do it, and it has to be rescheduled, reconfirmed, and again go back to the client's premises to actually execute the work and finish the thing. So this one they have to go back for some reason. And we have a third loop here, and this one seems to be that they just schedule the work order, the visit, the field service visit, but they don't confirm it. So they go straight there, and of course things will happen, and they probably will not. The client will not be at home or will not be able to receive them, so they have to reschedule and then confirm and then execute the work order and keep going, right? So with this tool we can start seeing some of the problems that are causing our inefficiencies here. As you can see here, for example, the average for this loop is for incidents that go through this loop is 5 days and 17 hours. When we have a SLA of actually 4 days. So this is causing the SLA obviously to be breached, right? So if we go back to our variants here, another thing we can do is track this SLA that we were speaking about. So if I again filter out, because I only have an SLA for when there's a field service intervention, right? So if I again filter out the call center solved incidences, and I go only to the ones that have field service, right? So now I've filtered those out and back to my 3,480. I can add another filter to see how many of these are actually making the SLA. So I have a duration filter here, and I say longer than, and we have 4 days here for the SLA. So I click in 4 days, I have this filter, and now what we see is that in 1,800 cases, we're not meeting the SLA. We're above the SLA. The average duration is 5 days and 14 hours, right? I can set this to duration and have a look at this. This, for example, is the most frequently executed variant. And this is theoretically the standard flow, but even here, we're breaching the SLA in 500 cases. And what comes to attention is that, for example, there's this delay between opening the work order and scheduling the actual visit of 2 days. It takes them 2 days on average between when the work order was open and they schedule the actual visit, and this might be one of the reasons why we're reaching the SLA. So I might want to add a filter here to capture how many times this is happening. So what I can do here is go to arc duration, and select the arc between opening the work order and scheduling, right? This is the transition between those two activities. And I can say it's longer than, and I'm just going to put here to give it a little bit of leeway, 36 hours, for example. And this will give me in how many cases this arc is actually being more than 36 hours. As we can see, we've got quite a number of cases here. Now, what I can do with this filter is I can save it for later. So let's call it longer than 36 hours, right? I can save it and I can use it later. Right there, it's saved. And what I can do with this is if I go here to my alerts tab, right, I can even set an alert for this, right? So set up a new alert. I'm going to give it a name. For more than 36 hours, right? I'm going to give it a medium severity. And what I do is I select the filter set that I just created, right? And I create the alert. I add the alert with that filter. Now, what that's going to do is with whichever frequency and I'm updating the information of the process here, which can be up to real time, it's going to be checking for these cases where the scheduling to the work order to scheduling is taking more than 36 hours, and it's going to send me an alert to my email whenever this happens, right? So I can be monitoring the process and getting alerts in real time or whatever the update time is to be able to manage these things, right? So these are some of the things that you can do with the filtering and the analysis capabilities of the tool. But I wanted to show you also what you can do in terms of KPIs, dashboarding, and prediction. So what I'm going to do is I'm going to share now another screen where I have what we've done here is we've created some simple Power BI dashboards for this demo, and these dashboards, what it'll do is they will they're very simple and they just give you an overview of what we've just been seen and let you dive deeper into it. It's Power BI. We can do it in other systems. This is very easy because our software is based on APIs, and we can very easily connect Power BI to the source and get this information. So what are we seeing here? We're seeing, an overall SLA fulfillment. So as you can see, it's pretty dismal. So we're not fulfilling the SLA in 58% of cases, right? And this is overall. But since we added the field with time extender to be able to segment this into installation and repair, those are two different field service groups, and I want to benchmark between those. I want to see what their performance is. So if I click on installation, right? Sorry. If I click on installation, I get their performance is even worse. They're only fulfilling the SLA in 28% of the times. If I click on repair, I can see it's slightly better, although still not very good. They're fulfilling the SLA 41% of the times, right? Now, what we have around here is the average duration of the cases where field service is involved. Here's the average duration of the cases where the call center is able to solve them online. And here's the average duration of the transitions between the different steps of the process. And here we have a set of attributes that we can use to characterize what's happening over here. So, for example, we saw earlier that the actual step between opening the work order and scheduling is taking quite a long time. It's the step that takes longer here, right? And if I click here, I can see if it's related to any specific attribute. I can see that it generally happens when it's an internet related fault. So that looks like this is the attention group that's attending this call. So it looks like the group in the call center that handles internet connections, etc., is a little slow in actually scheduling the field service interventions. We can see here almost double than the other groups. So by using this, I can relate to the attributes and start understanding who's doing what, etc., etc. And here, what we've done is, since we saw, the different variants at the beginning that correspond to different executions of the process. We can look at these variants individually and how they relate to the different attributes. So obviously, this one was the variant where it was only the call center solved the incident, and as you can see, we have no average duration for field service because there is no field service when this path is taken. We have the second one, which is the let's say standard of happy path here. And here, as you can see, we detected the no fault issue. So in a very large number of cases, at the end of the intervention by field service team, it's declared as no fault, right? So this happens in other variants too, but it's a lot bigger in the first variant, right? Okay, so we can continue to explore the different variants. Now this is stuck. Okay, we can explore the different variants. So we can click on this one, and this one is the reopening loop that we saw earlier, if as you might recall. And what we see is that this loop is related massively to a type of incidents related to the router. So this is something to investigate, because what might be happening here is that the call center is saying, reboot the router, and then that seems to solve the problem. But as we saw earlier, 6 hours later, on average, they call back and they say, no, the problem is not solved, and it turns out to be an incident. So this is something to look at. We can go to the next variant, and this one is this one, if you remember, is the loop where you went to the client's house, and for some reason you can actually perform the work. Again, if we go down here and we look at the attributes, we see that it's massively related to activation of service and the installing of a router. So this is a new internet service activation. And this might lead us to think that, and to investigate that, many of the times when you go to the client's house to install the service, to activate the service, you need to run it over the infrastructure of the third party, and they need to do some work before you can actually activate the service. So what might be happening here is that you have a miscoordination between your team and the third party provider of the infrastructure, and when they get there, the previous work has been done, so they have to come back at a later date. And finally, if I click on the last variant, this one was the one where we had no confirmation of the scheduled visit. They were not, confirming that visit, and this was resulting in having to go back a second time because the first visit wasn't confirmed. Here, what we see is not related to a service or a type of incident. It's related to a call center. So it looks like Valencia are not really confirming these visits, and we need to work with them. I don't know if it's training or whatever, to make sure that they confirm these visits, because many of the times, since they're not confirming them, the field service team gets there and has to return with the obvious cost associated to that. So this is a very simple, dashboard that lets you see what's happening and dig a little deeper into some of the things. And then we have a prediction tab. So we have within Imbervis an algorithm that we can train with the historical data to predict certain things. So here we've used it to predict the risk of fulfilling or not fulfilling or breaching the SLA, right? What the algorithm does is it's trained with the historical data, and based on this data and where in the process the actual in which step of the process it is, it can predict the estimated duration, and therefore it can give you a risk of meeting or breaching the SLA. So
Hey,
what
John.
we have here, sorry?
Hey, John, I think you have done half the consultancy project for this telco already. I think we should come to the questions.
Right, you're right. Okay, so let me just wrap it up saying that here, based on that, it will give you a prediction if you're going to meet or not meet the SLA. So you'll have some that are on track to meeting it, and some that are on track to really fail it, and you can do this in real time and take the necessary actions. Okay, so that's it for me then. Thank you for listening in, and we're happy to answer any questions that you might have at this point. Can this be deployed on premise? The Embarrass platform is we do it on an SaaS based service, but we can also implement it on premise. So if you want to have deployment on premise, we can certainly do that, and we can talk to your people, understand what the requirements are, define the actual architecture and the infrastructure needed, and we can deploy it certainly on premise.
Yeah, this is true for time extender. So you can do this fully on-prem, and you can do hybrid scenarios. You can do full cloud deployment. So you have all the flexibility, and wherever you do it, the data will always be on your side. Can I decide what architecture I want to use? Yeah, again, you can have different architectural options for how you want to build this out. On the time extender side, you can do on-prem, you can do hybrid, or you can do cloud. If you go on-prem, it's a SQL Server environment that will execute things for you. If you go to the cloud, you have all the options of Azure. And we recently added Snowflake support. So if that is your database of choice, you can also use that. We have also options for AWS, and we're working on additional platforms as well.
Same with Embarrass. You can have it on-prem, and if you want to do it on cloud, we have it on Azure, and we're currently working on having it on Google and on AWS, and that's going to be ready very, very soon.
What type of sources can we connect to? Yeah, so as I mentioned, the list is very, very long. There's more than 250 connectors. I have shown you just a couple of them. So we have all the portfolio from very specific connectors for specific systems. They are highly pre-configured, of course, but that makes it very easy to connect. But if you have a data source, let's say that is not so common, we have also very generic connectors that really make sure you can get to all the things that are in data sources that are also a bit more obscure. And in the end, you always have ODBC fallback option. So you really can get to everything, and you can also then feed everything to Inverbis.
And that's one of the great things of the solution, that we've run into situations in the past where we had to connect to some pretty legacy and obscure and really difficult to connect sources, and with the help of the connectors from time extender and the ease of accessing it, we've been able to pull out the data from there.
Is there the possibility to creating a new source connection? Well, yes, as I said, so let's say you always have the option to create something that is based on ODBC. You can always use that with Time Extender. If it's a REST API, there's a highly customizable configuration language that you can use. So yes, you can connect to everything, and for ODBC, you can really always leverage that framework to get to all the sources you want. Can you connect to MongoDB? I don't know from the top of my head if that's on the list, but I'm pretty sure we can also connect to MongoDB. Okay, where can I find the complete current list of connectors? So we actually the whole portfolio of connectors that you can see is the CData portfolio. So you can go to cdata.com and see the whole list of connectors there. Plus we have some additional ones for SAP and Oracle, which is a bit more customized. But the vast majority of connectors you can see on CData. And of course, you can download Time Extender for free. There's a free version that gives you also all the connectors, and then you can check them all out.
Yeah, and in that front, you can also access the Invarious platform for free to play with it. You just have to register. Of course, you've got limitations on what you can use, what connectors, and what the amount of data. But it's a good way of playing around and seeing what you can get out of process mining in your environment.
Okay, so last question here from Brian. How can we feedback from Inverbis to Time Extender? So as John mentioned, Inverbis is based on APIs, and Time Extender can connect to APIs. So basically, we include Inverbis again as a new data source based on the APIs they provide, and then we just pull the data out from there again, make it part of the data processing, and then feed it out, for example, to Power BI, as we've seen.
Yeah, and that gives you the power to sort of complement something that you might have already in Power BI, some KPIs or something like that, with some more process-oriented information, and you can build a richer set of KPIs that combines both things. Okay, so I guess if there are no more questions, I think we'll wrap it up for today. Thank you, everybody, for attending. I hope it was useful, and it gives you at least a flavor of what can be done with Time Extender and with Inverbis, and how powerful the combination can be in terms of simplifying the process of breaking down the silos and getting to the data so you can extract value from it. And of course, any questions, if you want a personalized demo, if you want to go deeper into any of the two tools or into the joint solution, don't hesitate to get in touch with us. Thank you, Frank, for participating. It's been a pleasure, and see you next time.
Thanks, John. That was great. Looking forward to it.